It was such a quick stop on the last one, but I was right at 14 minutes and 59 seconds. And if I go over 15 minutes, then it doesn't save for me. So back up for a second, just make sure we got this. We had 158 grams per 1 mole, and we actually have 937 over x. So if I cross multiply, I get 158 times x, that's this, and then 1 times 937. Then I gotta get x by itself, so divide both sides by 158. That lets me get rid of that. X ends up equaling, I see it ends up equaling 5.93. And that's moles, or dozens, of this big molecule CaC2H3O2. 2. Alright, so there's that final answer on that one. I'll do that for just 1 second, since we had to stop so abruptly in that last one. Alright, okay. So, we'll go on to the next one. Alright, next one we got 0.800 grams of calcium. So, calcium, we're talking 1 calcium times his mass is 40. So, that's 40. So, 40 grams of calcium per 1 mole of calcium equals, and we got really 0.800 grams of calcium. We want to know x moles. So this is going to be a little mole, because 1 mole is 40 grams. We only have a whole gram. Cross multiply, 40 times x equals 1 times 0.800. Get x by itself. There's x by itself. So you divide that out, and you're going to get 0.0200 moles of calcium, or 2.00 times 10 to the negative second. Alright, there's that one. On to the next one. There's a whole bunch of these, wasn't there? Alright, next one we've got. Nope. Actually, that's the end of number 55, isn't it? So now we go on to 56. Number 56 says find the mass of each substance. Oh, find the mass. So we're still talking about the green one, aren't we? Right. Now it's giving us moles, and we got to find grams. So it's the same idea, but our crisscrossing is going to end up a little bit different this time. So first one, we got 1.50 moles of C5H something H12. All right, so we're trying to find mass, so we got to do molar mass again. So I got to go 5 times 12 plus 12 times 1 for the hydrogen. So that's 60 plus 12. Oops, it goes back again. Go ahead and turn it back on without falling down. Alright, so we multiply this guy out at 72. So I got 72 grams of C5H12 per 1 mole of C5H12. Then on the other side, this time I want to know x grams if I have 1.50 moles of this guy. So I'm going to cross multiply. We're going to get x times 1. This is where the cross multiplication is going to make it easier. And 72 times 1.50. So this is x times 1, so I don't have to worry about dividing by 1 because that doesn't do anything. So x is by itself, really. And we have x equals 108. And that is grams of C5H12. So there's my final answer. All right, on to letter B. Letter B, they gave me 14.4 moles of F2. So we got to find out the molar mass of this guy. 2 times the mass of fluorine, which is 19. So that's what, 38. So we've got 38 grams of fluorine if I had 1 mole of fluorine. But I got 14.4 moles of him. And we want to find out x grams of him. Cross multiply x times 1 equals 38 times the 14.4. So x equals 547 grams of fluorine. All right, on to the next one. I got to flip the page over. letter C, they gave me 0.780 moles of CaCN2, calcium cyanide. Again, that 2 that's on the outside really means 2 carbons and 2 nitrogens. So I have 1 calcium times 40, plus I got 2 carbons times 12, plus 2 nitrogens times 14. So that's 40 plus 24 plus 28. Add those guys up and we're going to get 92. Right? I'm going to make sure that's right. That's what, 52? Yep, 92. Alright, so 92 grams of CaCN2 per 1 mole of CaCN2. I'm going to go to the other side. I don't have a full mole. I got 0.780 moles of CaCN2. Now I want to find out X grams of him. Cross multiply, X times 1 goes 92 times 0.780. So X ends up equaling, where am I at? There it is, 71.8. And that's grams of CaCN2. All right, on to the next guy. This was a lot of work, wasn't it? All right, next one you have 7, right? Let's see. Yep, 7. Couldn't read my own handwriting for once. 7.00 moles of hydrogen peroxide, H2O2. All right, figure out its molar mass. So it's 2 hydrogens times 1 plus 2 oxygens times 16. So that's 2 plus 32. So that's 34. So 34 grams of H2O2 if I have 1 mole of H2O2. Then I go to the other side and go, well, I don't have 1 mole. I got 7.00 moles of H2O2. I want to find out X grams. Cross multiply. X times 1 goes 34 times 7.0. And X is going to equal 238 grams of H2O2. That's our next guy. Next one. Next one, they gave me 5.60 moles of something. Sodium hydroxide, NaOH. All right, we got to find its molar mass. So 1 sodium times 23 plus 1 oxygen times 16 plus 1 hydrogen times 1. So that's 23 plus 16 plus 1. So that's like 40. So 40 grams of NaOH, or 1 mole of NaOH, equals, well, we got 5.60 moles of NaOH. I'm going to find out X grams of him. Cross multiply, X times 1 equals 40 times 5.60. Multiply that out, and you're going to get 224. Oops, not 22.4. I'm jumping ahead of myself. 224 grams of sodium hydroxide. All right, on to the next one. Last one on this question. Last one, we got 3.21 times 10 to the how many? -2. That's moles of Ni, nickel. So we're going to go 1 nickel times his mass, which is 59. So it's 59. So 59 grams of nickel if I have 1 mole of nickel. When I go to the other side and go, I don't have a whole mole. I got 3.21 times 10 to the -2 moles of nickel. We're going to find X grams of him. Cross multiply, X times 1 equals 59 times 3.21 times 10 to the -2nd. Multiply that guy out. Remember, don't type in times 10. That's type in exponent. All right. So X ends up equaling 1.89 grams. Small number of grams of nickel. There's my answer to that one. That finishes up number 56. All right, now we can go on to number 57. All right, 57 says calculate the volume. Ooh, we're actually volume now. Now we're not after mass, we're after volume. So which one of these up here is volume? Oh, it's the red one down here because it's got liters. So we're going to use 22.4 liters per 1 mole. Does it matter which substance it is? Nope, doesn't matter. Not in these ones, not in volume. Sweet. All right, so the first one, we've got 7.6 moles of the gas argon. So we're going to go to the other side and go moles is on the bottom, so we're going to go 7.6 moles of argon. We want to find out X liters of it. Just cross multiply. X times 1 equals 22.4 times 7.6. And X ends up equaling about 170 liters of argon. So there's the final answer to that one. Ooh, that was easy. A lot easier than the last one. All right, so we know these ones are going to be that same idea. So we're still using that 22.4. And the next one we got 0.44 moles of butane, C2H6. So we're going to do the other side, we got 0.44 moles of C2H6. We're going to find out X liters of that. Cross multiply, X times 1 equals 22.4 times 0.44. And X equals 9.86 liters of butane. All right, then we go to letter C. I might have my time. Okay. Oops, I erased my 22.4, didn't I? 22.4 liters per 1 mole. Remember, I wasn't putting in the gas on these because it doesn't matter what gas it is, really. So letter C, we got 1.20 moles of O2. Yep. So we're going to go to the other side. Well, that's on my bottom. I got 1.20 moles of O2. We're trying to find X liters of it. So X times 1 equals 22.4 times 1.20. Multiply that out and you get 26.9. And that's liters of O2. So there's my final answer on that one. So that was number 57. And then we got the very last one where we're figuring out density. I think in order to do this, we're going to jump to part number 4 because I'm almost to the end, so I don't want to overrun. So we'll see you in part number 4.